Ladies and gentlemen, this is Joe's Classic Video Games back with another cool pinball repair video for you this evening. This is a Stern Dracula. I have two of them. Aren't I lucky? Our buddy Shane brought us these two super cool machines. Probably because he knows that I like pinball machines. And also I like Stern pinball. And also I like Dracula. And I like Shane. He's a cool dude. He's alright. So we're going to fix up Shane's Draculas, and we're going to do this one first. So we did a previous video on this where we set them up, and we looked through them and everything, and we came to the realization that this one on the left was made before the one on the right, and we did a whole thing about it. If you haven't seen it, you should definitely go back and see the first video that we did about these Draculas. Now, this one on the left we think is in a little better shape, so we're going to fix it first, and Shane is going to keep it as his personal Stern Dracula, and he's going to give me the other one. Isn't that... Man, what a swell guy. He said something about he's going to sell it because it's worth a whole bunch of money. But I think really what he means is he's going to give it to me. So we'll see if that happens. I think that's what he meant. So we're going to fix this first one, though. We did a video, like I said, where we kind of went through it all. It looks like someone has repaired this one at some point. They've went through it. Because the playfield's been cleaned, and I don't know that it's going to get much cleaner, but we'll see what we can do. One thing I wanted to point out, we on the first video we showed it, but we had the glass still on it. If you look at this one, in this area, see how the playfield looks? This one has been cleaned up and waxed, but look at the playfield. You see all the little dimples in it? It's like there's little dents all over it. It's kind of hard to see, but... yeah, there you go. So it's not just a typical ball swirls. There's like little dents. Now this is something that popped up on the later Stern playfields, like around the time that they were doing like Pirates of the Caribbean. This is a completely different company, really. This is Stern Electronics. From the late 70s, and I'm talking about Stern Pinball from the mid-2000s. But the opinion at the time then was that these are actually dents in the playfield caused by the ball hitting it. Now the little swirls are common on all the old pinball machines, but the little dimples, the little texture to the playfield, I don't think I've ever seen that on an old one. It's almost like it's orange peel in a clear coat, but it's not. Like nobody has painted it. That's just, it's almost like the playfield's dented. Very strange. Now there is a kick out up here. So maybe the ball would land there after getting kicked out from up there. So you see as you get farther away from it, there's less of it. And then as you get closer to it, there's more of it. And in this one area, it's all over the place. It's like little dents everywhere. So see, look, right on that bat, there's tons of little dents in the playfield. If we look at our other one, it doesn't have that, but it has an area where the paint's been completely worn away. But if you look at the actual playfield, there's no dents. It's just dirt, right? But you can see the swirls, the little circular things. That's on every pinball machine. That's a very common thing. They call it ball swirl, right? But there's no dents on this one, and there's dents on that one. So that's the strangest thing. I've never seen that on an old machine. Now, it could be that yeah, look at that. You see it? It could be that they did that, and then eventually, if it gets enough wear, it kind of levels out or something. I don't know, but it's interesting. But it looks good, and this playfield is much better than this playfield. Much better. I mean, look at this one, right? Now you do have a flipper drag there. We'll fix that. But this one's just in much nicer shape, so we're going to roll with this one. But it does have that one little thing there. And, you know, if Shane's going to get both of the machines back, if he don't like this one, he can get the other one. But that's just interesting. So anyway, we need to try to get this sucker to do something, to talk to us a little bit. So we haven't plugged it in or anything. but that's what we're going to do. So if you get one that's an unknown condition like this one, it's got a bunch of stuff missing. You know, we'll show you how we work through them. So the way that we do it is we start at the wall, literally, where the plug plugs into the wall. So I'm going to take the back glass out and put it somewhere safe so we don't break it. And then let's find the power cord and see what kind of condition that's in. All right, so here is what's left of the interior of the back box. It's actually in pretty nice shape. It's just missing two of the boards. We have one of them up here on the top, along with some of our other goodies. It's missing the solenoid board. That's no big deal at all. It's missing the cap that goes over that. We might have that. I'll look around. No big deal. But so basically the power cord snakes in through the back and then goes down into the bottom of the cabinet. So I have looked over the entire cord. There are no cuts in it. And this plug is original and in great shape. So we're just going to leave it. What a cool thing, folks. Look, a power cord from 1979 in perfect shape. Okay, but we're not going to plug it in yet. So next I'm going to lift up the playfield. Let's look at where the power cord goes underneath the playfield and make sure everything's cool down there. So it comes in. It's tied through a strain relief so that if you pull on it, it's not going to pull loose. And then it's soldered to a line filter. The line filter on the other side is soldered to lines coming off of it, going to the switch up front and the transformer. So that is factory. That's how these were made. Now the electrical tape, again, is factory, believe it or not. You can see there where it's been removed from this line or it fell off or whatever. Okay, so we're going to put some new tape on it. That's how they did it from the factory. And just to, you know, keep this nice and clean. Now I wonder what's going on here. Too close. Back out. That's where the tape is. Okay, so I'm going to vacuum this up a little bit, and I'm going to put some fresh tape to dress that. And then, now you might think, well, why go to all that? Why are you taking it so slow? Because I want to know that the power cord ain't the problem whenever we run into all the problems we're going to run into. You know, I don't want to second guess stuff that comes early in the power trail. So you want to make sure you got good power in the wall, it's getting through the cable, it's getting to the transformer, right? And then you don't have to worry about any of that stuff. And we can troubleshoot deeper down the line. Okay, so yeah, let me get the vacuum, I'll clean it out a little bit and tape that up. Oh, also worth mentioning, the varistor is not burnt all to hell. So if the line gets hit by lightning, this thing will be shorted and literally will look like it caught on fire. So it looks nice and clean. It's probably still fine. Alright, so I vacuumed it out. I taped up the wires. We'll look at the other one and I'll show you that that's how they did them from the factory actually. And then the next thing that it does, the power comes through that. It goes through that taped wire that we just did. Taped and soldered wire, I should mention. And then it runs up here to the front and runs to this power switch. Now we noticed this on the last video. At first that looks fine, but if you look at it, someone's been a-messin'. So somebody put a new lead on that, which is fine, which would go there. By the way, we're unplugged, obviously. Let's see if that'll go back on. Yeah, it's actually on there really good. But look here. How do I have two lines here and only one here? Something ain't right. I mean, I think that switch may have been stolen off of another game or something. I don't know. Let's look at the other one. I'll show you what I'm talking about. So here is machine number 2. The cabinet is actually very different. We talked about that in the first video. But if you look, there's not enough light. Yeah, there you go. See the tape? That's just how they did them from the factory. Alright. And here is the power switch. Now see that it's got 4 screws, but none of them are in. But if you move it, you can see it's been like this the whole time. And the wires are different. So it looks like they've combined the white and the blue. Right? But they did not, for some reason, there are 2 white wires there with nothing hooked to them. So I think this switch must have been out of something else. Also see how the plate is even a different shape than the other one. But that could be because they changed the design of the cabinet right in the middle of production. So that's the early cabinet, that's the later cabinet. We figured that out on the previous video. So they made Nugent, and it had this type of cabinet. Then they made Dracula. About halfway through Dracula, they started making Trident, and Trident had this type of cabinet. So right in the middle of the production of Dracula, it appears that they swapped the way the cabinets are done. So I think that switch, somebody at some point has pulled out of something else. So how are we ever going to figure it out? Well, I'm going to look on the schematics. Let's check them out. All right, now we don't really need to go into all this much detail, but it's, you know, this is why we're making videos. I'm just trying to show interesting stuff. These are the schematics that we found in the bottom on the last video. And this is the MPU. They are huge schematics of the new MPU that Bally and Stern had created. So what we're looking for is a diagram of the power supply. Look at this cool manual. Awesome. It's so awesome. All right, where is our power supply schematics? Here we go. Nope, that's just the transformer. That's close, though. I think we might have one that actually shows cabinet and front door wiring. Isn't that cool? No date. Okay, so here we are. 120 volts AC ground and return. So here is the varistor that I was saying will burn up if it goes over 130 volts. You know, I've thought about this. All of these machines have 130 volt varistors in them, but in the United States, at least around here, the line voltage is 125 volts now. I wonder if they're ever going to stop the insanity. Does it really need to be 125? Wouldn't we be cool with it being 120? I'm just saying. If I start popping varistors because the line voltage is too high, I'm going to be upset. Okay, and then check this out. B, I wonder if that's the color of the line. They're saying yellow and white and G. Yellow, white, ground. Okay, so ground is going to the filter, and then the 2 wires come out, and here's the tape that I was talking about. And then they run up to the service outlet somewhere, and then there is a power switch. But it's only on one side. It doesn't show it on both sides. So in the one machine, it's wired on both sides, but, you know, the diagram shows that you really only need it on one side. So what's going on with that switch? They've got a black wire running to whatever color that wire is. I think it's yellow. And then on the other side, they have a white wire running to a blue wire, or a blue wire. They've got a black wire running to a yellow and a blue running to a white. But what they've done is the blue and the white are just together on one leg. So it's not, that neutral line is not actually switched on and off, which it doesn't really need to be. But they still have the 2 wires separated across the on-off switch that are the hot, right? And since it still has the original cord, all of that should still be the way it originally was. So in other words, we're just going to leave it exactly how it is. It's fine. But when you've got 4 legs on the switch, I said when you've got 4 legs on the switch, it's a double pole switch. So you're throwing 2 at the same time. This one actually though, is it? On and off. Yeah. So you can connect the neutral and the hot. So if this was drawn like that, you'd have this same thing over here on this line. So whenever you turn the power switch, not only does it cut that wire, it cuts that wire. It won't cut this wire because the 2 are soldered together on the one machine. Now on the other machine, they're separate. So why there are 2 cut wires, I have no clue, but they're not hurting anything, and it appears to all be correct. So all of that to say, we have worked with all of this and everything looks fine. We also cleaned up the cabinet a little bit. So now we're to the point where the power is going to run up to the transformer. Now I wonder if they show, yeah. So they're just basically showing this arrow, right? Now, and then what does it do? Well, on the transformer, you have 3 connectors. One of the connectors comes from the cabinet, and wait a minute. Yeah, here we go. Cabinet, J2 cabinet. This one says J1 playfield. This one says J3 backbox. So the J2 connector on the transformer and rectifier board assembly, or as they called it, the power transformer module, has the AC power coming in on a yellow wire and a white wire. Now, I know there's an arrow here, but you get it. So that's where the power comes in. So it comes in on these 2 wires, goes through a fuse, and then is soldered to the transformer. Okay, and then the transformer transforms, and it sends the power back out through all those connectors. But that is actually the input right there. Okay, so our next thing is we need to work on this transformer. Let's go get it out of the machine. All right, so this is what it looks like after you get it out of the machine. It was mounted in there like so, with the metal thing around it. And then this was mounted like so. Okay. Now, coincidentally, I just happen to have, just in case you're interested, this sitting on my desk. Somebody gave this to us a little while back. Look at this. This is a 1981 Stern power supply for one of their arcade games. So this was made in 77. This was made in 81. It's kind of interesting just seeing all of their vintage stuff. And it's kind of accidental. Like I said, we just had this sitting around because a guy mailed us a bunch of parts, and this was one of them. So it's kind of useless for a pinball, though, because it doesn't have the right voltages. It's got 12, -5, and 5. Which is perfect for a pinball machine. But not perfect for perfect for an arcade game, but not perfect for a pinball machine. So this is actually an older power supply, though. But they use these for years. And it creates completely different voltages. So what do we need to do here? Well, the first thing I'm going to do, and what I've been doing lately, I was just ranting about the line voltage a minute ago. This, see how it says 115 on the top? It's because from the factory they set it up for 115. So they would write that on it, I guess, and had a whole pile of them. And then the ones that they had set up for 220, they had probably written 220 on it. So if you get one that had been exported, I'm sure it says 220 right there where this one says 115. But like I said, the line voltage is actually about 125 now. So lately, whenever we get the opportunity, you don't have to do this, but if you get the opportunity, we've been changing it while we have it out of the machine. There is a little diagram in the cabinet that shows you how to do that. Let me see if it's in one of these little manuals that I've got here. That sounds like the type of thing they might put in a manual. There is a manual in here that says game general book. Stern's Games general book. Wonder if it shows it in there. Why, yes, it does. Let's see here. Does it say anything about that? Transformer wiring connection instructions. Okay, so 115 and 120 volt, 50 to 60 cycle input. Varistor soldered to the line filter on the left side of the cabinet. Must be Stern part number, blah, blah, blah. Solder lugs 1 and 3 together. Solder heavy red wire to lug 1. Okay, so it's saying 1 and 3. Now, if you look really close, it's kind of hard to see. It's written in red, of all things. 1, 3. So if you look, there is a wire connecting 1 and 3. So those two are connected together, and then the heavy red wire is connected to pin 1. And then it says, for 115, solder lugs 9 and 11 together, and solder the heavy yellow wire to lug 9. Okay, so 9 and 11 are soldered together, and then the heavy yellow wire is on lug 9. All right. For 120, solder lugs 5 and 7 together, and solder the heavy yellow wire to lug 5. So if the yellow wire is down here on these two soldered together, you're at 115 input. If it's here with these two soldered together, you're at 120. So what I've been doing is just moving it to 120. Just to help out a little bit with this crazy freaking voltage. Have any of you seen Better Call Saul? Where the brother starts going nuts and he's worried about the electricity in the walls, and he rips all of the power lines out of the walls and all of that. The older I get, the closer to that I'm getting. So this doesn't have to be done, but if you've got the thing out, you might want to consider it. What it's going to do is it's going to lower all the output voltages that run the coils, the lamps, all of that, and theoretically should stress all of those parts a little less if you have it set on the proper input voltage. So let me do that real quick. So I need something. I'm going to cut this wire so these two are not soldered together anymore, although that may not be necessary, but I'm going to do it anyway. And then I'm going to wrap something around these two to join them together, and then I'm going to move this wire up to here. All right, so it's real easy. So I cut the wire that was connecting these two. Right, I added a wire connecting these two and soldered the yellow wire to there. Now, if you don't understand why we're doing that, don't mess with it. Just leave yours alone. It'll be all right. So that's that. So we've got everything looks good on the transformer, no problems there. So hopefully we've got that taken care of. So now we need to move up to this little rectifier board, which usually has quite a few little problems. This particular one has some, corrosion looking almost on the legs of one of the resistors. I'm going to try to clean that off, and then we're going to test the resistor and see if it seems like it's still in spec. When those get green like that, sometimes they break. So if they're weak, you need to replace it. But if it's not really corrosion. I don't know what that is. I guess it must be corrosion or it wouldn't be green. But I don't know what that is, but we got to clean it up a little bit and make sure it's all right. So I'm going to get out the power supply schematics, and we can make sure that's within spec. All right, so I cleaned it up. It cleaned right up, so I think we're cool, but we're going to test it. The way I clean up stuff like that, you saw how it just looked. So the problem that you would have is if that crap has creeped up inside of the resistor or something, or if it's attacked this metal to where it's going to break. That's the risk of it, right? So the way I clean that up is I just take a bristle brush, a brass brush, and just go to town, scraping on it. Now the risk you run is you might break it, but that's what you're trying to figure out, is the damn thing going to break? I just brushed the crap out of it with this and it did not break, so that tells me it's strong and it's been tested. Right? So if it breaks, then it needed to be replaced anyways. Now, don't go over the top and abuse things, but that's, you know, stress test, baby. So what it is this little resistor right here. So there is 7.8 volts coming out of one winding of the transformer. And look, here it also tells us our jumpers. Right? So one attaches to 1. And then if 5 is attached to 7, that's 115, or 1 attaches to 3, and if 5 attaches to 7, that's 120 volts. But they had it set on 115 volts. Why would they do that? What are they doing? So anyway, back to where we were. So it is 7.8 volts comes off of one winding of the transformer. One side of it runs through a 10 amp fuse, and then it runs to BR1, Bridge Rectifier 1. Do I have that right? Yes. BR1, and across the DC side of BR1 is this resistor, and it says 25 ohms. And the DC voltage that you're going to get out of that is 5.4 volts DC. Now, what is that used for? Well, it is used for the feature lamp bus. Let's see if it says that on the other part. 5.4. Yes. Feature lamp bus. Right. So that is the volts that run the voltage that runs the lights that the computer can turn on and off. They call those the feature lamps. That's opposed to the general illumination lamps, which are just on all the time. On the more modern machines, it can turn the GI lamps off too, because it runs it through a relay that it can turn on and off. But so this is what makes your same player shoots again lamp come on. Is this voltage. Now, it's kind of confusing the way they have it, because you've got this, it looks like it's attached to CR1, 2, 3, and 4. But what's really going on is this is ground. Am I correct with that? Yes. This is ground. So these 4 diodes here do something different. It's just 2 of them are also attached to ground. So this resistor is across ground and the voltage that it puts out, the DC voltage. The DC voltage is actually coming from this bridge rectifier. So that's the positive, that's the negative. Which if you look, snakes around and is also ground, right? So this is across that side and this side. So it's as if this resistor was right there. So let's see if it's 25 ohms. So I'm very carefully checking across that voltage and ground, and it's 27.3 ohms. So 25, 10% would be 27.5. So as long as it's less than 27.5, it's dead in spec. If that's a 10% resistor, it's close enough. It don't really matter, right? We were just looking to see if it's completely collapsed or shorted or anything. Resistors don't usually short, but they open up. But anyway, that seems to be fine. Okay, next thing to do, we're going to check these 3 bridge rectifiers and see if they're working properly. Okay, so the way that you do that is the bridge rectifier has a, let's see if I can, do I have a pointer? I do, I've got a drill bit. The bridge rectifier has a little plus mark right here. That's the positive DC voltage. And there's a little negative right here. That's the negative DC voltage. Ground and voltage. The other 2 are AC lines, and they're interchangeable because AC goes up and it goes down. So it doesn't really matter which one's where in this instance. So that's AC and that's AC. This is positive, that's negative. So you've got AC being turned into DC in 3 different places. Now why would they do that? It's because they have 3 different voltages that they need to do. So one of them will give you 5.4 volts out of it. One of them will give you 11.9 volts out of it, and one of them will give you a big whopping 43 volts out of it. And it all just depends on the AC voltage that runs into each one. All three of these bridge rectifiers are identical. So the way you test a bridge rectifier is actually very simple. It's really just an arrangement of 4 diodes. And they've got it drawn like that on the schematics. So that's the inside of a bridge rectifier. There's just 4 diodes. And interestingly enough, on this board, they actually use 4 discrete diodes to do the same thing in one place. That's those 4 we were looking at a second ago. So for whatever reason, and I'm sure it's a good one, they designed this where instead of using a bridge rectifier, it just uses 4 diodes. And that's to create the 230 volt DC voltage. So maybe they did that because the bridge rectifiers that they use stock were only 200 volt bridge rectifiers. I mean, yeah. So the way you test it is you take your negative, you put it on diode test, your meter on diode test. I have a new meter that was sent to me that I need to start using, but I haven't got my bearings on it yet, but coming soon, new meter. You take your, so I've got it on diode test, also transistor test, whatever you want to call it. You take your negative lead, black, and you put it on the positive voltage on the bridge rectifier. And then you take your red lead and you put it on one of the AC lines adjacent to it. And you see if you get a proper gate voltage drop measurement, right? So between 0.4 or so and 0.7. So we're getting 0.486. Now when we go to the other AC line, we should get something similar. And it's exact, 0.486. But we've only checked 2 diodes. So now what you do is you take your positive lead and you put it on the negative. And then you take your black lead and you put it on one of the AC lines. 0.483. The other one is 0.483. So this bridge rectifier tests good on the bench. Now anything that tests good on the bench doesn't necessarily mean that it tests good in the game, because once voltage runs through it, you might get a different result. This meter actually is sending voltage through the lines. That's how it works, but it's only sending like 10 milliamps or something. I'm not good at measuring that, but a very low trickle is going through here. That's how the meter works. That's why you need a battery. It's not just to light up the display. But once you put it in the machine, you're running 12 volts, and in the case of these diodes, you're running 230 volts through them. So it's a different story. So you can find a bad component on the bench, but you can't find a good component on the bench. 0.474, 0.474, 0.477, 0.477, 0.479, 0.479, 0.467, 0.467. So all 3 of those bridge rectifiers test good on the bench. Now I'm going to try these 4 little diodes here, and we're testing them the same way, just like a standard diode test. I've found, although I'm sure it's not universal, that if you get the proper voltage drop one way, then you always get the correct blocking the next way. So it should block power going back. But when they're arranged like this, sometimes it doesn't necessarily do that. But we're just looking for something that's shorted. All of those seem to be working perfect. Okay, so I believe our bridges and our diodes are fine. Now I'm just doing this because I'm trying to do a full service on it, But in the game, you can just check the voltages at the test points. And if one of your voltages is missing, then you can look at, well, let me check the bridge, let me check the fuse, let me check blah, 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 right? But since we have it out of the machine, we're doing the whole thing, I'm about to show you why I have it out of the machine. We might as well test everything the best we can here on the bench. So the next thing I want to check is to see if the fuses are the correct value and if any of them are blown. All right, so I removed everyone and checked them, and they're all fine and they're all correct. That's probably a first. Some of them appear to be the original fuses. This one here has been replaced at some point, and you can see one of the little issues is that on modern fuses, this one's the new one, they're a little bit shorter. It might be hard to see. They're just slightly smaller. So it was a little loose in there, so I just pinched these, I pulled the fuse out, pinched these together a little bit, and put the fuse back. That's just the difference between imperial and metric, I believe. Okay, so I'm going to next take the board off because we need to get to the back of these connectors and see if there's any issues back there. So the way you do it is you have 3 little screws here through the middle of the bridge rectifiers that are mounting them to a heat sink underneath the board. And by the way, I don't know if I mentioned it yet, but this board looks really clean. I mean, this is in very nice shape considering that it's 45 years old. So here's the back of the board, a little dirty, a little dusty, but it's not burnt. Sometimes you'll have it all charred up where it's just been running juice through it for decades. This one I think was put away quite a while ago. Okay, so our only real concern back here, you never have a problem really out of the soldering of the wires running to the transformer. By the way, all of that is all of these lines here. See where it says E11, E12, E10, E9? Those wires, these are on the PCB. These are the wires running to the transformer. And you can see it's also soldered at the transformer. So the leg of 14 of the transformer solders to E10. 15 of the transformer solders to E11. So that's what all this is. So this is like E whatever, and it goes back and it solders to lug whatever. All right, so all of that can be repaired and redone. If you buy a new, you can buy these rectifier boards new. If you buy a new rectifier board, you have to swap all those wires to the new spots. It's not that big of a deal, but it's if you get one of them wrong, bzzz. Okay, so we want to see if these connectors have bad solder on them. So usually at the end, they will have broken solder joints. Now you saw when I was pulling on the lug, the connector earlier, you saw I was flexing and everything. That's what breaks those solder joints. I didn't really mind because I'm going to resolder them anyway. See this one on the end here? It doesn't look all that great. See how you can tell that the pin is square? Because that's kind of see how it almost looks like there's a crack right at the edge running down through the solder. That's because of probably me when I was pulling on it, or if not me, the last person that owned it, or if not that person, somebody 30 years ago that you and I have never even heard of. You know what I mean? So this is old school stuff. That's why we're looking at this. Now down here you can see the whole end of this one solders to the same plane, so usually they're not as bad. And it's usually at the end because whenever you're pulling on it, that's where all the stress is. Yeah, it is broken actually. See that last one? That is a picture perfect example of a cold solder joint. That has completely separated from the solder around it, and so that wire that's connected to that pin will not work. So if that's, for instance, the ground, that wire will not be grounded wherever that goes. Well, I'll tell you where it'll go. Let me just see here. let me look at these schematics. Okay, so the long one is to the back box, and at the end there, that is the solenoid return bus. So that's the ground for some of the coils. The one next to it, the one below it there, is also the solenoid return bus. The one below that is to the display ground. The one before that is the 5-volt return that runs on the MPU basically. Okay, so that's that connector. Now here we did that one already. Which ones did we do? Okay, so we got a bad one there. A bad one there. Looks like we've got a bad one there. It's not as bad, but it's going. And then on that end, it looks pretty good. Nope, look at the end one. See the little line about halfway up the mountain there? That's cold solder joint. So what are we going to do? Well, I'm going to resolder all of them, just simple as that. And I've had people ask, how do you do that? There's different ways to do it. The way I do it, I'll just tell you my technique here. You take a wire brush and scrub the crap out of them. You're trying to get all of the dirt and impurities and everything off of it, so you've got the solder as clean as you can get it. And then you just carefully add just a tiny bit of solder to each one of them. And whenever you do that, it'll reflow, and whenever it reflows, the new solder joins the old solder, and it kind of collapses, and you end up nice. Now, you can remove all the old solder if you want, but it's metal. If people are telling you that you can't reuse the metal, they're lying to you. You can reuse it. You need to mix it back up. But you can reuse it. It's metal, people. Metal conducts electricity. Okay, so let me clean them up and resolder them, and I'll show you my solder mountains. I don't show people how to solder because whenever you do stuff like that, you get all of the technical jerks telling you you're doing it wrong. So I'd rather just avoid all that by just telling you, I don't know how to solder. You should listen to the experts. They're real good. Okay, so I threw the solder on it. Now, if you do this, and on yours, you end up with little black rings around the posts, it's because you didn't get the pins clean enough. You didn't get the contaminants off of the old solder. Like that one. See that one? So that one is probably electrically making connection just fine, but see the black, see how it's kind of pitted and everything? That's because there was still some kind of contaminant on the pin, right? Now all of that flux is the flux inside of the solder that I'm using. And all of the little mountains are a little higher because I added a little bit of solder. But that's good. You're good. Everything's cool except for that one is a little questionable there. I might redo that. But that'll get you going. Of course, the risk you run of adding too much solder, you just add just a little tiny bit. If you add too much, you're going to short it to the one next to it that it shouldn't be shorted to, unless it's something like this. Where, see, I purposefully kind of shorted them all together because they're all connected to the same plane. All right, now on one of these, look at this little number here. There are traces on the front, under the connector, that need to be well soldered as well. And the only way to do it is to get the back very hot and make sure that it flows through. So see how, for instance, that trace runs under to this pin? So you just need to get this pin really hot on the back so that the solder wicks down through the board. All right. Oh, and by the way, here is the 25 ohm. It is a 10%, so very cool. All right, so I'm going to touch up the solder a little bit more, and then we're going to put it back together. Okay, so these pins, the last thing we're going to do is check them out. Now, you could clean these, but on this particular machine, they are so clean, I'm not going to do a thing to them. It's still in really nice shape. You can also replace those, of course. So if you want, you can order those new, and instead of resoldering the back, take the solder off and then put new ones in. But that's the type of thing people do when it doesn't really have to be done every time, especially if they're really nice like this. Now, if some of them look burnt and it's pretty nasty, yeah, swap them. And some people, see how these are square? See how they're square? The new ones, a lot of them are round. Now what's the difference? Well, if it's round, the pin, when it slides down in, is just touching one little part of it. If it's square, the pin's touching one whole side of it. They also make trifuricon, I think that's what they're called, pins, where they grab all three sides of the post. Those are all right. You know, you can do it if you want. But again, I don't really think they're necessary. That's just my opinion. Some disagree. Some people like to spend every possible penny they can on them, but those people in general aren't even going to fix this board. They're going to buy a brand new one. Personally, you know, I don't mind spending half an hour working through the original one, and then it's still got the original board. Look how beautiful this thing is. It lasted 45 years. We've just done a little bit of service to it. Didn't need much. And hopefully it'll last another 45 years. And somebody, someday down the road, will open this up and go, oh, wow, look, it's got the original board that the old school tech fixed up, and the thing's still got all the cool stuff in it. Right? That's how I see it, folks. All right, so let's go pop it back in the machine and see if we get any action or any fire or what happens. All right, folks, so we mounted it back in. Now, I plugged in the connectors. We probably need to repin those, although this is an exceptionally clean machine. None of those are burnt or anything, but I just plugged them in for the light show, for the purpose of the video. I've unplugged the lamp board power. I've unplugged the soundboard power. The solenoid board's missing. The MPU is missing. And I've unplugged the two displays that were left in the game. Now, why did I do all that? It's because I just want to see if the lights come on. Let's turn it off. Let's turn off the power. I want to see if the lights come on. If the lights come on, that will be its first sign of life in quite a while, right? So let's see. We're looking for smoke in the dark and to see if any lights come on. Heck yeah. Lots of lights. Very cool. I don't see any smoke. The panel board also has a lot of lights working. Cool. So all the GI works, but that's not... All that means is you're running juice through them, you know. But very cool. That's always one of my favorite parts, is watching them come back a little bit at a time, right? Okay, so let's check the power supply, though, and see if it's putting out the correct voltages. And if it is, then we're done with the power rectifier, and we don't ever have to worry about the power again. It'll probably last forever. It'll never be a problem. You know, we're trying to do Shane a solid. Yeah, so let me set up the camera, and we'll check the voltages on the power supply. All right, so my arm might be in the way, but look, folks, you'll be all right, okay? Don't worry about it. So we'll do DC voltages first. So to get a ground on this, one of the places you can grab it is this bottom leg of this resistor here. Okay, and then you can put your red lead inside of the test point connector. So TP1 is 5.81 volts. Oh, I should look in the schematics to see if that's correct, shouldn't I? Luckily, I have them right here. TP1 on this, it says 5.4. On the schematic, in reality, we're getting 5.8. Now what is that? That's that extra wall line voltage that I was talking about. Okay, so that's that one. Test point 1 is good. You don't need these to be dead on the money. You just need them to be in the ballpark. Now I'm about to screw that all up with this one. Watch how off this one is going to be. So it's 180 volts, but it's supposed to be 230 volts. Now why is that? It's because there's no capacitor here to raise it up. It's just the way the thing's designed. When you plug in the solenoid driver board, there's a filter capacitor on there that raises the voltage up to like 230. And then they rectify it down to 190 originally, but we usually set it on 180. So that's actually correct as well. Test point 3. Here we go. .3. It's supposed to be 11.9. Notice it is also 0.4 high, like our other one was. Test point 5, we're going to skip 4. I'll tell you why here in a second. Test point 5, 44.6 volts. It's supposed to be 43 volts. That is the solenoid voltage. So that's actually, slightly high, but again, it's because the input voltage is slightly high. Now we're going to go back to test point 4, and the reason we skipped that one is because it's actually AC. Okay. So yeah, my meter just plugged into the board with this in the air is 0.7. It is supposed to be 7.3. It's 6.6. I've had that before. It's because we've got the, I believe, we're going to test it. It's because we've got the lamps plugged in. So that is the general illumination voltage. If I were to unplug the playfield and the back box and then test it again with none of the lamps on, I think I unplugged the wrong connector. This is the playfield. And this is the AC. Is that correct? Now it's a little higher, 7.0. This is saying 7.3. Close enough for me, right? Because whenever all the lamps were on, it was still up at like 6 something, and the lamps are 6.3 volt lamps. So if you're anywhere near that, everything's cool. So notice that a bunch of the voltages were in the area. You're not really looking for them to be exact. You're looking for them to be, because none of those are regulated. They're all just either AC or they're rectified DC voltages, but they're not regulated. So they're going to be a little all over the place. But what you're looking for is the 12 volts that's supposed to be the 11.9. Is it 2 or is it missing? Well, then you know you got a problem. Okay, the solenoid voltage that's supposed to be 43, is it 120? Well, you got something really screwed up, So you're just looking for if they're in the ballpark. And after you do it a while, you can just tell real quick by looking at it. Like I can do one now, go through it, wham, 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 yeah, close, good, that's good, that's good. It's no big deal. So, Shane, your power supply, completely good. Everything's cool on it. It's wonderful. What a great power supply. Very cool. Now here's the kicker, people. If we would have just plugged the machine in, it would have done exactly what it's doing right now. We didn't really fix anything. All we really did was preventative maintenance. We replaced some tape that was missing on the bottom. We made sure all the wiring was fine. We took the power supply out, did some preventative maintenance to that, made sure all the fuses were fine. But if you would have just plugged it in, it would do exactly what it's doing right now. The lamps would come on and nothing else because it doesn't have the MPU in it. But now we know that stuff is good. Everything's taken care of. You don't have to worry about any of that stuff, right? So you end up with a much nicer product if you work through it systematically and know that everything's been taken care of. So there you go. So next time we will find a solenoid driver board and keep working through it. Hope you enjoyed it so far. Leave your comments below. Boy, what a The art's really cool on this. Look at this chick. She looks terrified. He's like, hey, baby. And she's like, repulsed. There's the scratching that we were thinking. I think the other back glass is going to be better. And remember I was saying that I thought his leg looked like it had problems? Yep. And then here's the angry mob. That's almost like a Frankenstein thing. All right, folks, so there you go. Hope you enjoyed it. Leave your comments below. Like I said, make sure to give us a thumbs up for taking the trouble to film it for you. We didn't have to do that. And while you're at it, check out my brother Donnie. If you didn't know, my brother Donnie has his own channel here on YouTube. I work on arcade games, jukeboxes, and pinball machines with my brother Joey. My brother Donnie does old buildings, old vehicles, things like that. He has a farm with cows and goats. And so I'm over there with him on his channel sometimes, messing around. So go check that out if you haven't. We'll see you back here in a couple days where we will continue with the undead here and see if we can bring them a little farther back to what we call life. So I hope you enjoyed it so far. This is Stern's Dracula.